In session 57 here and in the sessions following, we're going to be going over polynomials. Polynomials being some of the more advanced types of algebraic expressions. There are different kinds of polynomials. We're going to start with monomials here in this session. First of all, a monomial has a format of some constant, a, being multiplied by a variable x, and that variable x is being raised to a particular exponent, and in this case n represents the exponent. Well, the constant here has a special name in a monomial. It's called a coefficient. A here being the coefficient. Once again, x is your variable and then n is the exponent. And the degree of your monomial is represented by the exponent of your variable x. So for example, if we had x to the 10th here, x to the 10th power, the degree of this particular monomial would be the 10th degree, because the exponent that you have for the variable x is a 10. If we had 6x to the second power, the degree of this particular monomial, 6x to the second, would be 2, because your exponent is 2. So let's go ahead here and take a look at a couple of different examples of different monomials. This will be pretty quick. In our first one here, we have 13 times x to the second power. Question is, in this monomial here, 13x to the second, which portion of this monomial is your coefficient? Well, if you back up here, the constant a that's being multiplied by x to some power, that is your coefficient. So down here, 13 would be our coefficient. 13 represents a in this standard format. What is the degree of this monomial, 13x squared? Well, the degree is represented by our exponent for our x variable. Our exponent is 2, so the degree of this monomial is 2. So this entire chunk here, 13x to the second, together as a group is referred to as a monomial. Another example, let's say you had minus 6y to the fourth. Now remember, just because we have x up here in our format, our standard format for a monomial, that doesn't mean that the variable always has to be an x. It can be any other variable, any other letter in our alphabet. X is just the one that's chosen to be used in this particular format. So here's our second monomial, minus 6y to the fourth. In this monomial, what is a? Our a is our coefficient, and our coefficient in this monomial is minus 6. What is the degree of this monomial? Well, it's 4. That's represented here by our exponent. And in this situation, our variable is the letter y. So once again, minus 6y to the fourth. This entire phrase, this entire chunk, is referred to collectively as a monomial. Well, we also have another less obvious example, and here's the number 7. Question here is the number 7 a monomial? Well, at first appearance, the answer would be no. Why? Because there's no x, there's no variable that's being raised to a particular power. However, can this number 7 be written or rewritten as a monomial that has the exact same value? The answer is yes. Because what we can do is we can put 7 times x and take x to the 0 power. And if you remember from a few lessons ago, any number that's raised to the 0 power is always 1. So if we have x to the 0 power, what is the value of x to the 0? Well, the value of x to the 0 will always be 1, no matter what the value is for x. And what is 7 times 1? It's still 7, the original 7 that we started with. So 7 is a monomial as well as every other individual number. 16, 95, a million, all of those are also monomials because they can be written by themselves being multiplied times x to the 0 power. X to the 0 translates to 1, and 1 times the number you started with is just the number that you started with. Okay, let's move on to a couple more examples here, and then we'll be done. Let's say our problem is 12x to the third plus 3x to the third And then from that, we're going to subtract 6x to the third. Let's determine what the value of this is. First of all, are each one of these three terms monomials? Is 12x to the third a monomial? Yes. 12 is a, 3 is n. Is 3x to the third a monomial? Yes. This 3 here is a, this 3 here is n. And is this minus 6x to the third a monomial? Yes, the minus 6 is a, and the 3 is n. When you have monomials, you can simply combine them together and have a very quick addition or a subtraction problem. For example, 12x to the third, well, over here we have 3x to the third, and the degrees of both of these monomials are the same. They're both to the third power. Same with this third term. It's also to the third power. When you have monomials that have the same degree in them, you can simply add and subtract them based on their coefficients. So then, what is 12x to the third plus 3x to the third? Same degree, so we just take our coefficients and add them. 12 plus 3 would be 15. So then, 12x to the third plus 3x to the third is 15x to the third. Now, take that 15x to the third and subtract from it 6x to the third. Well, they still both have the same degree. 15x to the third has a degree of 3. 6x to the third has a degree of 3. Therefore, we can just simply add or subtract our exponents. Well, here we have a subtraction sign, so we're going to be taking our 15x to the third and subtracting from it 6x to the third, and that's going to leave us 9x to the third. So our answer here is 9x to the third. One other thing before we move on to the review is that the degree of a monomial has to be the same in order for you to add or subtract the monomials together. However, the degree of the monomial does not have to be the same when you're multiplying monomials together. If you remember from earlier sessions, when you have individual terms that are being multiplied by each other and they have the same base, here we have 3y to the third being multiplied by 6y to the sixth, or our variable is y, and our variable is y. What is y to the third times y to the sixth? Well, when you have the same base, when you multiply it by another term that has the same base, you just add the exponents together. Y to the third times y to the sixth is y to the ninth. Then we take our coefficients and multiply them together. 3 times 6 is 18. So 3y to the third times 6y to the sixth equals 18y to the ninth. Is our answer here 18y to the ninth a monomial? Yes. 18 is our coefficient, a, and 9 is our degree, our exponent of n here. So quickly, a monomial is in the form of a times x to the n, where a is called the coefficient, and n is an exponent, which also represents the degree of the monomial itself. And once again, the degree is important when you're trying to add or subtract monomials, because you have to have monomials of the same degree before you can add or subtract them together. And then lastly, individual numbers themselves, like 10, 3, 0, a million, etc., are also called monomials. Okay then, that finishes up session 57.